Good morning, everyone. My name is Yan, and I'm an engineer at a company called SpaceSafe Games, where I make mobile games for a living. As you can see, I've got a bit of contraption here today. Don't worry, it's a 24-hour blood pressure monitoring system, but in about 2 minutes, it's going to beep. There's no need to worry. Don't need to evacuate the room or anything. I'm not going to collapse on the floor either. It's just going to have to stand really still and let it take my blood pressure. Otherwise, it's going to keep retrying because clearly they haven't learned to use circuit breakers yet. So with that, I've actually been a quite long time user of AWS. It's coming to almost 10 years now since I first started using services like EC2 and S3 and so on. And the last 2 years, I've worked quite extensively with AWS Lambda in production, including working on some non-trivial serverless architectures in one of my previous jobs, working for a social network startup in London. And since then, I've been really active in writing about and sharing my experiences as well as many of the lessons I've learned whilst I was working with serverless technologies. And some of that has been picked up by the Serverless Architecture white paper published by AWS. And I'm here today to talk to you about observability, which I think has definitely entered into the mainstream thinking in 2017, to the point that we now have a full-on observability track at a massive conference like QCon. And I think that is in part thanks to the excellent writings by people such as Charity Majors, as well as Cindy Sriharan. And in her post, Cindy talked about how the first mention of observability came from a post by Twitter, maybe going back even a few more years, where they were discussing the challenges and problems that they run into in terms of debugging and monitoring and troubleshooting this massively complex distributed system that they have built. Which begs the question, at least for me, of what exactly is observability and how is it any different from just plain old monitoring? And the best way I can think of to explain the difference is that monitoring is like having a guard tower where you're looking out for those known system failure modes, like someone climbing over the fence or trying to rush the gates, or in our case would be maybe spikes in CPU usage or network I/O or memory usage. And it's the sort of thing that are really well suited for being displayed on a dashboard and platted all over your office, whereas observability is maybe closer to what, say, intelligence agencies are doing in terms of monitoring your data about you and me, and to help them understand this massively complicated system of human interactions by only observing from the outside, hence the name of observability. And in her interview with Daniel over there for InfoQ, Charity talks about how when you have a complex distributed system, the health of individual services now become less important because they no longer tell the full story. By the way, it's happening right now. You're witnessing live blood pressure taking. So I'm just going to stand really still and talk. So when you got a complex distributed system, the individual health of one service can no longer tell you the full story of what's happening. It's hard to tell the causal link between the health of one service to the level of user experience that your users get when they interact with your system. So instead, we should focus on those user actions instead and try to improve our ability to debug and troubleshoot those complex interactions that are happening inside the system. And that means we need to collect data from different dimensions, and the telemetry data that we collect for monitoring is just one of those dimensions. And unlike monitoring, observability is also very useful outside of incidents and outages. And quite frankly, when you're dealing with a really complex system, you're going to need to have very good observability just to be able to understand what the hell is going on and to be able to operate this system in production. And of course, as people started building more and more complex distributed systems, they also created tools to help them gain observability in both the open source space with tools like Zipkin and Open Tracing, as well as commercial offerings as well. Unfortunately, all of these tools and practices that has been building up in the last couple of years, they also evolved the previous generations or paradigms of how we build and ship software to run inside EC2 instances or inside containers. And of course, when Amazon announced the AWS Lambda, and then we got this new paradigm of serverless computing, it's introduced a number of interesting challenges to this existing set of tools and practices that we have built up. For starters, we now no longer have access to the underlying infrastructure that runs our code, which means we can't install monitoring agents and daemons that for a very long time has been really quietly going about their job outside of the critical path where we're really concerned about minimizing user-facing latency. So all of these agents and daemons, they will collect the logs and metrics from your system, and you batch them up and send them asynchronously in the background. But with technologies like Lambda, you now lose the ability to do background processing. Another interesting thing that has changed with the serverless paradigm is that whereas before, the level of concurrency is largely managed and controlled by our own code, but with Lambda, that management of concurrency has been lifted up into the platform, which on the face of it is great news for us because it means our code has now become drastically simpler. On the other hand, we also lose a certain economy of scale because whereas before, those logs and metrics will be collected and batched up at an instance or container level, whereas now they have to be, at best, batched up at a per concurrent execution of your function. Which means in terms of the concurrency that we project onto the downstream system that we use for collecting and monitoring our system is now, the level of concurrency is now far, far greater than before. You might say, sure, there's a simple solution for that. You just use a bigger batch size. Unfortunately, that's not quite going to cut it either, because imagine when there's a high level of traffic hitting your system and Amazon is now creating new containers to run your code in response, which is great because your system is auto-scaling without you even have to think about it. It just happens magically. What happens then if you are batching and collecting those metrics and logs data in between invocations and not sending them eagerly? And what happens when that traffic goes down? Some of those containers are no longer necessary. They become idle, and eventually they'll be garbage collected by the platform along with any data that you have collected but have not yet sent to the monitoring system yet. So if you're batching and sending your data, then there's a very high chance for data loss as a result whenever those garbage collection happens. So you might say, sure, in that case, we just send those metrics not eagerly at the end of every invocation. Problem solved. Unfortunately, remember, there's no more background processing, which means now you've got to do those as part of your function's invocation. And so that adds to the duration for your function invocation. And when you're talking about APIs with API Gateway, it doesn't respond until your function actually finishes executing. And in the meantime, your customer is still waiting for something to happen because your app is still waiting for your function to finish executing. So you get caught in this catch-22 situation where, on one hand, if you are batching and sending metrics data, then you have data loss. On the other hand, if you are sending them eagerly, then you're adding to your user-facing latency, which, as we know, can impact revenue as well. Another thing that I'd like to mention is that with serverless technologies, event-driven architectures has become much more commonplace. And this is a post by Randy sitting there. If you want to find out more about event-driven architecture, go talk to Randy afterwards. And I think in general, we've seen the rise of event-driven architecture with serverless adoption, I think in part because it's just become easier to implement them. With technologies like Lambda and Kinesis to create the event-driven architecture, it's actually really simple. And in general, we're also seeing a lot of functions being chained together by asynchronous event sources, such as SNS messages, or Kinesis streams, or even DynamoDB streams or S3 events. Whenever you drop a file into S3 bucket, that can trigger a Lambda function. So in order to trace those asynchronous event invocations, it's actually quite difficult, at least compared to those synchronous invocations like API call. So that's just some of the challenges that this new serverless paradigm has introduced to the practices and tools that we have for observability. And so let's talk about some of the tools that we do have available today. There's, of course, in terms of the 4 pillars that's been identified by the Twitter engineers in terms of monitoring, alerting, and visualization, disability tracing, and log aggregation. And of course, there are more tools than there's more tools and vendors in this space than you can count. So I'm just going to focus on the tools that comes with the platform with AWS. Whenever your function writes to send it out, that message gets captured by the Lambda service and shipped asynchronously to CloudWatch logs. And this is one of the few background processing you do get because it's provided by the platform. And in addition to your log message, you also get a UTC timestamp as well as a unique request ID as well. And the way logs are organized inside CloudWatch is such that for every Lambda function, you get a matching CloudWatch log group. And inside that log group, you have one log stream for every container that's running your code. The problem with CloudWatch logs is that it doesn't make searching easy, especially if you need to search across all of your functions. So what people would tend to do in practice is that they would go to CloudWatch Logs console, select a log group, action, and then say, I'm just going to stream all of my log events to Amazon's managed Elasticsearch service if I'm using that, or more commonly, to stream them to a Lambda function, which you can then ship your logs to whatever other log aggregation service you're using, which could be Loggly, could be Splunk if you can afford it, because it's really expensive. One thing to keep in mind is that for every time you create a new Lambda function, the system also creates a new corresponding log group in CloudWatch logs as well. And what you don't want to have is a manual process for someone to go in there to have to manually configure the log group to then stream it to your log shipping function. And what you can do in this space is to enable CloudTrail on the account, which then allows you to create an event pattern against the create log group API call that the system makes, so that every time a new log group has been created, you can trigger another Lambda function. I can't really see. You can trigger another Lambda function whose job is to subscribe this new log group to your log shipping function. And this is something that you have to do once per environment so that you get that as a platform, as a capability for your platform. But if you're using the serverless framework, you can also just put this into your function definition as well in your serverless or YAML, so that every time you deploy a function, this project to your environment, you also get that as a capability. Another thing to keep in mind is that whenever, by default at least, whenever a new log group has been created, it's set to never expire. And if you're going to be shipping your logs to somewhere else already, then it really doesn't make any sense for you to keep all those logs in CloudWatch logs forever, especially as you're also paying for data storage with CloudWatch logs as well. So again, apply the same technique, enable CloudTrail, set up the event pattern for create log group API, and then invoke another function whose job is then to set the retention policy to something more reasonable, like 7 days. And by default, you get a bunch of basic telemetry about your functions from CloudWatch, including function invocation count, duration, error count, throttle count, and so on. And oftentimes, you want to record application-level custom metrics as well. But remember, no background processing. So again, you've got to do it as part of your functions invocation, which makes your API slower. And OK, you may say that's only 10, 20 milliseconds. But when you've got microservices, those 10, 20 milliseconds can start to compound when you have a user action that requires several APIs to complete. So those 10, 20 milliseconds per API call you're adding can easily add 100 or 200 milliseconds overall to the latency that your user experiences. And a few years ago, even Amazon found that every 100 milliseconds you add to their latency will reduce the number of sales by 1%. So those additional milliseconds you're spending to send custom metrics can actually end up coming back to haunt you and hurt your revenue. So one of the workarounds available in this space is that you can piggyback off one of the background processing you do get from the platform by sending metrics asynchronously, by first writing them as a specially formatted log messages in CloudWatch logs. So that gets captured by the service, sent to CloudWatch logs asynchronously, and then your function that ships logs can then pick those up and send them as metrics to your monitoring system instead of logs. And this may sound like a really strange thing to do, but actually a lot of the tools that are designed with serverless in mind are doing that already by default. So Thundra, which is a new monitoring tool from Opsgenie, they do this by default. And Dashboard, for those who are familiar with the serverless space, they also build a monitoring system for serverless applications. They do the same as well. Another company that's really doing some really interesting stuff around serverless security, PureSec, they also do this to record the security-related information so that they can display and filter them on their platform as well. In terms of approach, well, this approach is going to add latency to when you see those metrics in your dashboards, and it's also going to add cost with the use of CloudWatch logs as well as Lambda invocations. And one more thing to consider is that with Lambda, there's a regional limit of, by default, of 1,000 concurrent executions and, in one region. And what you don't want to do is when you have so many things that you're logging so many things that this log shipping function are invoked constantly because it's an asynchronous event source, that you end up eating up your quota for your regional limit and cause first top priority functions such as those servicing APIs to then get throttled instead. So you want to use the new ability we have to control concurrency for individual functions and make sure that this guy doesn't run wild. In return, you're not going to add any latency to your function invocation for tracking custom metrics and so on, which I think is a pretty good trade-off, but it's definitely not the right thing to do for every situation. What I would say is that when you've got APIs where you're really concerned about user-facing latency, maybe consider this approach to send metrics asynchronously, but for everything else, where you're doing background processing with Kinesis or SNS, just send the custom metrics as part of your functions invocation because those additional latencies are not impacting your user experience. And once you have all of your metrics in CloudWatch or whatever monitoring system you're using, create dashboards, set up alarms, hook them up with your Ops Genie or whatever, usual things that you would do already. And in terms of distributed tracing, Amazon also offers the Xray service, which allows you to see what goes on inside an invocation for a particular function. Especially if you're taking the time to instrument your code, then you get a very fine-grained breakdown of what's happening inside your function and where those milliseconds are going. And interestingly, if you call another function from that first function via Lambda's API, then you also get a breakdown for that second function as well. Except it doesn't work when you call a second API, a Lambda function via API gateway, because as of now, Xray doesn't support API gateway natively, but it's being worked on by Amazon. Still though, from my experience, the use of Xray is largely focused on what happens inside one function. So it's good when you want to home in onto some performance issues that you know about a particular problematic function, but it doesn't do enough for you to help you gain intuition and understanding about how your system is connected together, the composition of your serverless architecture. And again, going back to the same interview with between Daniel and Charity, the health of individual services are now less important in this world when you're dealing with a complex distributed system. Instead, in here, I like to follow the data as it enters into the edge of my architecture as a user request, and then just flow through various parts of my system via both synchronous invocations like via API gateway, as well as asynchronous invocations via Kinesis or SNS or S3 events and so on. Xray, of course, offers a service map view for the traces that you collect, but just as the traces themselves don't span over asynchronous event sources, the service map itself doesn't review those either. So it may be good for you to get a quick overview of how your function is connected to the various components and a high-level overview of their current health. It doesn't do very much for you to call those entire call chains. And of course, being an AWS service, it doesn't really help you when it comes to tracing resources outside of AWS ecosystem. So if you're using Auth0 or you're using Azure functions as part of your architecture because you want to use the AI services available in Azure rather than the ones in AWS, Xray is going to help you trace those invocations. And finally, I know I've got the option to just go to the dashboard, keep pressing that refresh button to see new traces as they come in. But that feels like a very static view for a system that is alive and things are constantly happening. Why am I sitting there looking at the dashboard and just constantly clicking the refresh button? It's just silly. And we'll talk more about this later, but for now, I just want to conclude this session by saying that I think our tools right now, they're very focused on helping you understand what happens inside your function, whereas I think in the future, they need to shift that focus slightly to then focus more on the interactions of your functions and what happens inside your whole system by looking at those user actions that have a tendency to cut across multiple parts of your architecture. And this is one of the architectures that I worked on my previous company, where we migrated a monolithic backend system for a social network to run on serverless. And one simple user action could be I create a new post. It should get distributed to all of my followers' feeds so that the next time they come into the app, they will see my new post on their timeline. Exactly like how Twitter timeline works. And for a very simple user action like this, you can see a number of functions have to work together to make this feature work. And they have to work together via both synchronous invocation events such as API gateway, as well as asynchronous event sources such as SNS and Kinesis. And as people build more and more complex systems using serverless technologies, I'm pretty sure that this is the area where we're going to need the most help from our tools. And that brings us to what the future of serverless observability could be. based on some of the things I've seen in the people actually working on new tools or new features for existing tools, but also some of the ideas that I have myself as well. Starting with dashboards. As an engineer who's done a lot of on-call and operational work in my career, I've used a lot of different dashboards from different vendors, and by and large, I've disliked most of them for the simple reason that for every useful bit of signal, I have to filter out myself a lot of noise. And I also get this mental dissonance whereby most of my tools focus on what happens inside one component, and yet when I want to ask the question of, is this component healthy, the different dimensions of data I need to look at are splattered all over the place. Some are in that corner, some are at the top, and I can't even work out where am I going to find my one service in this mess here. Which is why, of all the dashboards I've used so far, the one I enjoy the most is the one that you get from a Historics library from Netflix, whereby all the high-level, useful, and relevant information about one component is nicely in one place, and the most important piece of information around the volume of traffic and the overall health of the service or the component is also the most prominent and visually striking part of the dashboard as well. Unfortunately, in terms of data points that you get from Historics, it's just not fit for serverless, because it's got information we don't care about, like the number of hosts, for example, but it's also missing data points that we do care about, such as number of cold starts or the number of concurrent executions and so on. So what if we are able to apply a little makeover to the Historics dashboard, and we keep the important information up there around the volume of traffic and health of the service as the most striking and visually prominent part of the dashboard, but then we'll substitute in the number of cold starts both in absolute terms, as well as percentage of the number of invocations, say, in the last 2 or 5 minutes. And also, since we know how much one invocation is going to cost you, Amazon even reports how much it's going to cost you in the CloudLocks messages based on the function invocation duration, as well as the size of your function in terms of the memory setting. We can actually give you an estimate on how much this function is costing you, say, per second or per minute rate. Also, we can tell you the current concurrency that you have for this particular function as well, and as well as any the number of throttled or errored invocations, alongside with all the other tail latency numbers that we are monitoring as well. And it's all well and good having all this information, useful information in a dashboard, so it shows us the health of individual functions. It still doesn't tell us how my system is composed together via the different functions and different event sources. And the way that I like to visualize my system is as if it's a brain, where you've got neurons and you've got the synapses that connect them, so that allows data to flow through the brain. And when you want to see how the brain reacts to external stimuli, you put someone into an MRI machine, and you watch in real time as different parts of the brain lights up as you inject those external stimuli by, I don't know, pinch their arm or tickle them or take their blood pressure. So if you apply the same design thinking to dashboards, maybe you end up with something like Netflix's Withrow tool, where you can actually watch as traffic flows through your system. Imagine all of those little dots could be Lambda functions or it could be event sources. Or maybe how traffic is being diverted when one of the AWS regions is having an outage. So having a live dashboard rather than a static one is going to give you a bird's eye view into your system as it breathes and as it leaves. And maybe occasionally you want to take a pause on watching the little dots move around across the screen, and you want to just pick out one of the current execution threads and really dive into it. And here we're going to need to be able to trace those asynchronous asynchronous invocations, and also we need to trace over services that we're using that are not part of the AWS ecosystem. And also, instead of forcing me to jump between different tools to see different views of the same trace, I should have all the logs relevant to this particular thread of execution right there at my fingertip. And should have the usual treatment for UX in terms of being able to click on the column to sort by different columns, or click on a row to expand it to see other attributes I'm collecting with my log messages. And if I click on one of the functions, it should also just filter out everything else to show me only the logs created by that particular function. And since the tool also knows that I've clicked on a function, maybe you show me a little tooltip so that I can very quickly pop open the Cloud9 IDE to look at the code so that I can easily correlate between the log messages I'm seeing just now with the code that's generating those log messages. And I also want to see the input and output for my Lambda functions when I'm looking at them, so that should also be right there available where I need it as well. And as I navigate to another function, it should show me the new log messages as well as the new input and output for that particular function. And if one of my functions errored, I also want to see the error message as well as the stack trace if one is available. And finally, the tool should make those functions that didn't complete successfully very visually prominent so that I know straight away that, hey, that's the function I should investigate. So that's all well and good, but we're still missing some information around the performance tracing. So we're probably going to care about how long the entire workflow took, as well as the breakdown for the different parts of that call chain. And if I click on one of the functions, maybe it should just filter out the noise so that it shows me, highlights me the traces relevant to that particular function invocation. And if I took the time to instrument my code, then I also get more fine-grained breakdown as well. So the idea here is that the tool, I should have a tool where I can satisfy all of my tracing needs rather than having multiple tools that shows me different views of the same trace and then only then mentally build up a complete picture of what's going on in that trace in my head. The tool should just show me the picture rather than give me clues of what's happened and then force me to piece everything together. Another thing that strikes me when I look at a dashboard like this is that it's actually a graph, as in you've got nodes and you've got vertices that connect them. So what if we are able to store those traces data as a graph data and be able to query them as a graph, as you would do in a graph database like Neo4j or Amazon's new hotness Neptune database. So wouldn't that allow us to then be able to query based on the relationship between the different components that we are observing, as opposed to just about, say, some characteristics about that component, like average latency or error count or so on. You may ask, why is that useful? And I think it's useful because whenever you're doing a root cause analysis, as the name suggests, you're looking for that causality that helps you understand what caused some abnormal behavior that you were able to observe or was being reported by your users. And oftentimes, when you start to investigate these abnormal behaviors, you start by looking for other abnormality in your system as a whole, just blindly, looking only for temporal correlation. But those temporal correlation doesn't necessarily mean causality. Oftentimes, it's really hard to tell the cause from the symptom because things all happen around the same time, and they show up on your graph at different scales. And I think for me, the reason that is difficult is because the relationship between the different components whose metrics we're looking at are not always obvious to us. And that's why you often have to fall back to the experts of a system, people that build a system, because chances are those relationships only exist in their mental model for the system and not recorded anywhere else. Maybe in the documentations, but documentations go out of date as well. So what if then? Imagine a world whereby those relationships can be captured explicitly and also queried upon. So instead of blindly looking for temporal correlation across the entire system, I only look for temporal correlations in the things that this particular, say, the payment service depends on either directly or indirectly. Then maybe I can much quickly identify that the root cause here is that we have seen an elevated number of throttle executions in one of the DB tables. And since being used by the user service, which then causes the user service to be slower, but maybe not so much that it triggers our alarms and alerts. But where we are seeing a symptom is actually in the payment system. So now that we have identified a place of interest, we can also expand the search to see what are other things that depend on this particular table, either directly or indirectly, so that we can find other components that could have been impacted, but not to such a severe degree that it trips our alerting and monitoring systems. So I think that would be a really useful extra dimension tool, or at least tool to add to our tool belt when it comes to monitoring and operating our systems. And the last couple of years, we've also heard an awful lot about big data, about machine learning, about deep learning. And I think as an industry, we've gotten very good at using those technologies and those techniques to help improve the product and services that we offer. What if we then turn around and say, can we apply the same ideas and same techniques to improve the way that we operate our software? Maybe we can use machine learning to help us auto-detect erroneous and suspicious behavior in our system, or maybe to suggest potential improvement that we can make. In fact, if you look at what's happening in the cloud providers, Amazon's already doing this with services like GuardDuty and Macy. And I think Azure is also doing this as well with their Cloud SQL offering, where they can offer you suggestions on maybe you should turn on this index, because had you done that, you would have improved that query speed by X percentage. So imagine now we have a system in the background that's constantly learning about how our system is operating, and maybe it'll tell us that, hey, one of your functions just starting writing to a DynamoDB table that is never done before. Is that right? That feels a bit suspicious? And if you're in the dashboard, maybe it shows you the pop-up so that you can quickly react to it. Or if you're not on the dashboard at a moment in time, then maybe send you an email as well with actionable links. You can say, oh, yeah, it's fine. It's a new feature. We know about this. Don't worry about it. Or maybe something is fishy. So you can tell the tool to automatically update the IAM permission for that function to put a stop to whatever's happening until you've had a chance to investigate further. Another thing you may be able to do is, well, you see that last time you did a deployment yesterday, and now your function is running on average 30% slower than before the deployment. So maybe you've introduced some performance issue, and you maybe want to look into it. Or that your function is averaging 102 milliseconds, and since the Amazon Lambda builds your function invocation in 100 millisecond blocks, so you actually get charged for 200 milliseconds. So maybe you want to increase the memory setting for the function so that you bring down the average execution time to under 100 milliseconds, and therefore it's faster, and you also pay less money overall as well. So that's just some of the ideas I've had for where we could be heading in the future for serverless observability. Of course, I don't have a crystal ball, so I can't tell you exactly what's going to happen. But this is just my wishes and based on the things I've seen so far. And Simon Wardley, who is a noted advocate for serverless technologies, he will also talk about how businesses need to develop a sense of situational awareness, and they need to do that. They can only do that by using tools that show them the context and movement of the space that they're operating in. And equally, as engineers who are building complex systems where we care about those user actions that tend to cut across multiple parts of our system, we also need to use tools that show us the movement and context of data so that we can build the situational awareness we need in order to operate our serverless architectures. And as Alan Kay would say, the best way to predict the future is to invent it. And I guess I'll follow that by saying the best way to invent the future is to inception someone else to do it for you, which has been the entire purpose of this talk. And with that, I guess also I'd like to thank a few people who are definitely inventing the future of serverless observability for showing me the stuff that they're working on. And as I mentioned already, Sandra, the Opportunity guys have created a new tool that's right now focused on the Java runtime, but they're looking to support other runtimes as well. And also, I looked at some of the things that the Owl Pipes guys are working on in the pipeline, and it's definitely very, very interesting. But the one tool that's probably got me most excited over the last couple of weeks or months as I prepare for this talk is this guy's called the Epsilon. They are startup based in Israel. And as you can see from the prototype, like a demo for their tool, I've taken a lot of ideas in terms of visually for what you could do in terms of how you want to monitor and trace your function invocations across both synchronous and asynchronous event sources, as well as in and out of Amazon's ecosystem. I think those guys are going to open beta pretty soon, so check them out when you have a chance. And if you want to learn more about SRE in general, or just observability in general as well, here's quite a few people that you follow on Twitter. With that, shameless self-plug. I'm also working on a course with Manning to share some of my experiences with running AWS Lambda in production. So do check it out as well. That was supposed to thank you slide, but I guess I don't have that anymore. Thank you.